Hi there! Welcome to a new episode of Stay.coti.io live stream series. I'm Percival Lucena, your host for today, and I have with me Rafa Fuentes. Hi, Rafa. Say some words to our audience.
Hello there. I'm so happy to be here. I'm gonna help you everything you need, and yeah, thank you for the episode, Percival. Um, Great. Thank you so much.
Awesome. Thanks, Rafa. It's a pleasure to have you with us. We also have Robert. Robert.
Hi guys, I'm looking forward today to dive into some vibe coding. And I heard some intriguing ideas coming by about private ERC-20 tokens. So looking forward, Percival. Let's dive in today. Thank you for having me.
Cool. We are here today to explore an exciting new topic, private ERC-20 tokens on the COTI blockchain network. As you probably know, all the token transactions on a public blockchain network are, guess what? Public. When you hold a token, anyone can see how many tokens you have from you, who you have received them, when you have received them. It's like your banking statements were public on the internet for everyone to see it. Well, when dealing with assets in the real world, you do expect some privacy for your assets, right? Like your car ownership information, your house ownership information, or even your medical records. You want to keep them private and control who can see them, right? So, COTI has a solution for that privacy problem. COTI is a layer 2 privacy on Ethereum, and now it's integrated to several other blockchains through the cross-chain platform using XLR. So we can use those private ERC tokens we are gonna build today. So only participants who have the right AS keys can decrypt the balance and other private information we keep on our token. We imagine several scenarios where private ERC tokens can help. Things like central digital bank tokens, confidential loyalty programs, real world assets, private DeFi. There are many cases we can create tokens where we keep the information private, so only a few people who have the right access can see that tokens and interact with that tokens. To make clear how those private tokens behave, I'm gonna share my screen here. I'm gonna start showing you some few things. Okay, I hope you see my screen now. I'm sharing with you my MetaMask account for the COTI testnet. You can see that I hold some private tokens and some public tokens on that same wallet. So what's the difference between private tokens and public tokens? For public tokens, everything on the token is exposed on the uh, blockchain explorer, so everyone sees that information, all the transactions on that token. And for the private tokens I hold here in my wallet, everything is scripted. It's encrypted. You see that I have two private tokens here. One is called TT, that was created by Rafael a while ago, and the other one is called Percy, that I created a few moments ago.
How do you know they're
So those
private? How do you...
How do you know those are private? That's a good question. You can go to the blockchain explorer and see the address of my wallet, right? So that's if you know the address of my wallet, you can see all the public tokens I have. So I have here three public tokens that are called Percy, right? Those are public tokens. Everyone can see them. It's exposed on the blockchain. But those other tokens I hold here, like the TT and this other one that's also called Percy, it's kind of private. Uh, today you're gonna create a new token called Capibara, right? And it's gonna be a private token. So only the person who have the right encryption keys that we call the AS keys would be able to decrypt the balance. The thing you see here is just a random number. It's not the correct balance of my wallet. I don't have this huge number of TT tokens, nor this huge number of Percy tokens, right? This is just the encrypted version of my balance. It's not the real version of my balance. So the real version of my balance and all the other information of the token is encrypted. So you cannot see that information on the wallet, and you cannot see the information on the blockchain explorer either. The only way that you can see that private information is creating what we call a specific client. That's a program that's gonna interact with that tokens and decrypt that tokens so you can see the full information of that tokens. That client is based on the COTI ethers library. That's a specific library that the COTI project has created that allow us to create those DApp applications that interact with private tokens and private information that's stored on the COTI blockchain. So in order to create those private ERC tokens on COTI, we will use different tools from our last live stream. So instead of using just a web browser with Remix and Replit, we're gonna install some AI developing tools in our computer. And those AI development tools, they have the latest AI models that will help us to create those private tokens and also interact with those private tokens. So I choose Cursor AI. There are many different tools to create AI-based code. We have Cursor, we have Windsurf, we also have Microsoft Copilot. There are so many different tools that allow us to create low code using prompts. For this live stream, I have chosen Cursor. Cursor is a free tool that's available for everyone to download on that specific URL, cursor.com. Cursor is a tool that's everyone who is familiar with working with different kind of editors will be very familiar on how Cursor work. So besides downloading Cursor on my machine, I also gonna need to use a GitHub repository. And why do I need this specific GitHub repository, right? Because we need to train the AI to create those private ERC-20 tokens for us, and the AI needs some examples on how to create those tokens. Why the AI is not able to do that without those examples? For everyone to know, COTI is like a superset of the Ethereum EVM. It allows you to create simple private, simple tokens and simple smart contracts, but it also allows you to create those private tokens and private smart contracts we want to create. So in order to create that, the tool really needs some examples. So I have created some prompts for you. Those prompts are available on my GitHub. You can find the URL for this GitHub on the video description below the screen. So if you're watching this through the YouTube channel, you're gonna see a link to my GitHub in the video description. And this GitHub, it basically has all the prompts you're gonna use today to create the ERC-20 tokens.
So because it needs it because it's so new that you have to give examples because it cannot scrape it from the web yet. Is that right?
Yes, though, if you use those tools without those examples, you're gonna see that Gemini and also other tools we have installed here, as like Claude, they're gonna search the internet for the examples, but they won't find the examples there yet. So they're gonna get lost, and will take several hours for them to find all the information it needs to create the private tokens. So in order to make things easier for everyone, I have created some examples of private tokens and private smart contracts, and we're gonna use those examples in our prompt. So the tool, we're gonna use that examples to create a new token we're gonna call Capibara. As everyone probably knows, Capibara is like a mascot for the COTI, right, Robert? I don't know too much about that history.
I've seen some pass in the community, yes.
Yes, okay. So that's our favorite mascot, and I'm gonna create a private token to hold our capybaras. So in order to use that, the examples we created, we basically, you're gonna probably need to clone or download this GitHub repository on a directory on your machine. And when you finish downloading my repository, you're gonna see that it has some folders here with some examples for COTI contracts, COTI ethers, and also for COTI hard hat template. COTI ethers is the library we use to interact with the COTI blockchain. It's based on the COTI on the ethers library, but it's a superset that includes all the cryptography functions to encrypt and decrypt information that's private on the blockchain. The COTI contract has several examples of smart contracts you're gonna use. And the last thing is the COTI hard hat template. The hard hat template is a tool we're gonna use to deploy the smart contracts and interact with the smart contracts. It's a tool that's available to interact with different blockchains like the Ethereum, Avalanche, and other blockchains. And we're gonna use that tool to create scripts that are command line programs that interact with the blockchain. Like they deploy the smart contract, they invoke functions on the smart contract, and do everything we need to interact with the token we are going to create. An alternative to using the hard hat template is using the Remix IDE. On my last live stream last month, I showed you several examples on how to use the Remix IDE. So today I'm gonna use something different. I'm gonna use the COTI hard hat templates to interact with the blockchain. So that's the general idea for today. So I think we can get started.
Yo, Percival, before we start, where can we get this template? Like in GitHub of COTI, or where exactly?
Yes, it's available on the COTI GitHub, but it's also available here on my GitHub. So the GitHub example we're gonna use for this live stream session is this github.com COTI ERC-20. It has everything you need here. It has the COTI contracts, the COTI ethers, the COTI template. Everything is included here. So you only need to clone this repo to do the private token sessions today. And as I said, the link for this GitHub is also available on the video description on the YouTube channel. Okay, so besides downloading Cursor, in order to create the tokens, you also need to install, to have a Node.js installed on your machine. So I assume you already have Node and you know how to install Node. If you have some problems installing Node.js, there's also a link on the GitHub on how you can do this. So
Otherwise, the prompts will easily tell you if you.
yes, otherwise, as soon as you start running the prompt, you're gonna get an error message saying that you don't have Node.js installed on your machine. Okay, so the smart contract itself is a Solidity smart contract. That's the standard programming language for the COTI network. And we're gonna create this smart contract for creating a Capibara token using our AI agent that's available on cursor here on the right top corner. So this kind of agent that's available on cursor allows you to choose what kind of AI you want to use to create your code. So the same prompt might have different results depending on the AI you choose. So for this demo, I'm gonna choose Gemini Pro because you usually get some good results using Gemini, but if you choose another AI, you're probably also gonna go right. So when you download a cursor, you already get some credits, free credits to use those AIs on cursor. All right. So the first thing we want to do is to make sure that we have this environment set up correctly. So I'm just gonna go to the terminal here and I'm gonna type some commands to install the libraries we need. So I'm on the root directory, I'm just gonna run npm install here. It's gonna download COTI ethers, COTI hardhat, and other libraries that are necessary. Okay. And I'm also gonna install the specific hardhat templates I needed to interact with the smart contracts. Okay, so I have all the dependencies I need to run the tutorial, so I can get started creating some code. The first code I want to create is the smart contract itself. And there's already an implementation of this smart contract that's provided on the COTI documentation. So if you see the COTI documentation for private ERC smart contracts, you're gonna see that creating a smart contract is something really simple. You just need to import the private ERC-20 library and give some parameters like your token name and your token symbol. But we want to do something different here. We want to create a new token that whenever this token is deployed on the network, it will automatically mint some tokens and deposit those tokens in our Ethereum address or in our COTI address, right? So
there's an element of luck in there as well.
Yes, we want that. If we create that token and we don't pre-mint the tokens, we're gonna need to manually mint the tokens afterward, right? So we can hold that tokens. We're gonna do that later on this live session, but in order for things to get more simple, when I create this token, since I'm the token owner, I'm already create some 10,000 tokens for myself. So when I deploy this smart contract for the Capibara tokens, and start this token on the COTI network, I'm gonna go to my wallet and I expect to see 1,000 capybaras there, right? Without doing anything. So this smart contract, it will have some specific logic that whenever I deploy this token on on the network, it will automatically mint some tokens for myself, right? And I also gonna include another function that would allow me to mint new tokens and transfer those tokens for other people, right? So that's our goal here, to create a token that will automatically include those tokens for the token owner. So I need to include some things here for the prompt to work. That's what we're gonna call the context. The contexts are the examples we provide our prompt for the prompt to understand how to do the tasks we are asking it. So I'm including the COTI contracts folder, and I'm also gonna include some other specific things here. I'm gonna include the standard private ERC-20 token that's provided by the COTI team. And I'm gonna also include here my previous token example I created. Oh, okay. So what I'm asking here is to create a new contract called Capibara.sol that inherits from the standard token example that COTI provides us, and it uses the COTI contract tokens examples, and it mints a new token to my address here. So my address here, it still don't have any capybaras. If you go here to my wallet, there are no capybaras here, and there are also no capybaras here on the Blockchain Explorer. So I'm gonna ask that contract to create this 10,000 capybaras and add them to my address, so I can see and interact with them when this token is finished. All right, let's run our first prompt. Fingers crossed. Okay, the first thing is we got a limit on Gemini Pro. Let's switch to Gemini.
Is that a limit because you had too many requests today?
Yes. Every 24 hours, it resets your limits of how many calls you can do. But since it provides different versions of Gemini, it's all right.
Looks great.
A lot of
with comments. Yeah.
Yeah.
What is going on there? Well, it's great because it documents for the user or for the developer which function is and how it works and all that stuff.
It's nice to see the reasoning. Yeah. It's almost like a book. With some functions in between. Okay, now we get okay. Yeah.
Yes, you see that behind the scene, it uses the COTI library MPC core. That's the library that's used to encrypt and decrypt functions information on the COTI network, right?
Yo, Percival, about that, it includes or how many agents know about MPC library when you add the COTI contracts directory as a prompt into the chat, or how it works?
Yes, exactly. When I add the COTI contracts directory to the prompt, it has several examples that teach the Gemini AI how to use the MPC library, right? So, okay, here's the final version. And there is a folder here called contract/tokens, where there is some examples, right? So I'm gonna add my contract here. The contract is just created here. I'm gonna apply this to capibara.sum. Okay, so we're gonna come here and try to understand what it has created. You see that it automatically imported the smart contract that is like the base smart contract for the private ERC tokens. It also included the MPC core library that's used to encrypt and decrypt. It created here the contract called Capibara, right? It has some information like the owner of the token, the total supply. That's one of the things we asked it to create, right? And it also added some information about who is going to receive the tokens. Here's the address I offered. That's my own address here on the blockchain of the wallet. I want the tokens to be added, right? So it already created that to this specific variable. The amount of the tokens I want to be included, which is 100,000 tokens. It also created a constructor here that sets the token name and the token symbol, right? And it also created this MPC core code that sets the amount of tokens to be created and uses the mint function to mint that token, right? So in order to invoke those kind of functions on the smart contract, you need to, since those are private information, you need to encrypt and decrypt that information using the MPC core. So it already created this code for us that is encrypting and decrypting the information on the private contract. So that's what the prompt is doing for us. It's not just a simple smart contract. It's a smart contract that uses the COTI libraries to make sure that all the information of this contract is kept private. So here it also created a mint function for us that allows, we're gonna call it later, to mint some new tokens. And also a function called public transfer that allows us to transfer this token to other people. So that's it. That's the smart contract for the Capibara token. Now we're gonna need to compile this smart contract and deploy this smart contract on the COTI network. I'm gonna use testnet for that. So the first step here is to compile the token. So in order to compile the token, we don't need to do much work. We just need to go to the COTI contracts function folder, and we're gonna use the standard hard hat compile command. All this information, I'm just following everything I'm doing here, is described on the
repo.
All the steps I'm following here, yeah, it's on the README MD that's on the GitHub repository. So I'm just running the npc hard hat compile to compile the smart contract I just created. No further magic here. So as expected, we always get some warning here, but that's okay. About the Solidity version I'm gonna use, that's okay. And we didn't specify a license for this contract, which is also okay. No no error. Those are only hard hat warnings. So when I compile my smart contract, it creates some compiled version of these smart contracts under the artifacts folder. This is something that a hard hat handles. So here now on the artifacts folder, it has created a compiled version of my token here. I should have some special information here for the capibara.sol, hopefully. Here is the token itself. I'm seeing the contracts, right? And probably want to see the build info and other things. Okay. Okay, so I have the token compiled, right? No error message. The token was successfully compiled. Compiled one Solidity file here. That's what it shows here. Now I have this token compiled. The next thing I want to do is to deploy that token into the COTI network, on the test network, right? So in order to deploy this contract on the COTI test network, I needed to create a deploy script for that on hard hat. Unfortunately, to compile, I don't need to do anything, but to deploy it, I needed to create this script. So I'm gonna use Gemini again to do that.
Did you build up any preference for Gemini?
Looks like I got some audio issues here. Let me try to
Okay.
switch back. Can you hear me well?
Yeah.
Yep. We can hear you. It might be your Bluetooth. Yep. This will work. But
Okay, there are some audio issues here. Are you still hearing me?
Yeah.
Okay, let me try switch back to.
We hear you fine.
Okay, I hope there is no echo.
There is not.
Okay. Okay, so let's go back. What I was saying that our second step here is to create the deploy script so that token, we can interact with that token we just created on the COTI network. So there's a second prompt for that. We're gonna use the second prompt, that's create the deploy file.
Yeah, I asked you if there was any preference for Gemini in this case because you were using it, or it was just because of the tickets.
Well, there's no preference, right? Since every time we run those prompts, we might get different results. I'm using Gemini here, so it's more predictable, but it also works with Claude and other AIs that's installed. I tested with Claude a while ago. It also works really, really well.
Okay.
So I'm gonna ask it to create a script similar to the standard deploy script that's provided in our examples to deploy our Capibara token and create a script similar to deploy to this Capibara token. I think I'm copied the prompt twice. Let's make sure that. So it's a really short prompt. Create a script similar to deploy.ts to deploy Capibara sol Sol token to, and let's hit the run.
So Sol is a Solidity contract, right? But JSON is an object. Why are you deploying two?
Well,
What's the
this
reason?
is the source code, and this is the compiled version we just created here, right? So we have created, when I compiled the program, it created something we call ABI version. That's the compiled version of our code. So I'm providing the script, the source code, and the compiled version to make sure it has all the information to deploy our contract. If I provide only the source code, it will probably work as well. But the more information we provide our prompts, the higher the chance that it will create the right thing, right? So
Okay.
So it has created something really simple here that's a deploy.capibara script to deploy our program. So now here on the scripts folder, I'm gonna add this specific version here too. Okay, so this is a simple script to deploy. And now that we have the script and we have the smart contract, we have everything we need to deploy the token, the Capibara token we just created. So that's what we're gonna do now. We're gonna run that script. And luckily, if everything goes right, after running that script, we're gonna see the new Capibara token added to my wallet. So in order to run that script, there are a few commands you need to run. Those commands, they are available here on the README file. So that's a single command you need to execute to deploy the script.
But we should add our private key, right, from our account before deploying?
That's a very good question, Rafa. You're right. That's the second time I'm running Hard Hat. The first time I run Hard Hat, it creates a script, a configuration file for Hard Hat here that keeps that information in the project. So yes.
So even in this environment, it already recognizes you're the owner and only you have the permissions to.
Yeah, Hard Hat, it looks for the key to deploy in my env file. So a env file is something that it creates when you run Hard Hat for the first time. It's gonna create you this env file where you're gonna store your private key and your AS key. And it's gonna use that information for deploying your smart contract. That's something that happens the first time you run Hard Hat. Since I already have run Hard Hat once in my machine, it has already created that for me. But if it's the first time you are running Hard Hat on your machine, it's probably gonna ask you that information. And it's gonna store that information for you, your private key and your user key on that env file. And when you run the deploy, the Hard Hat, we're gonna use the information that is in this environment file to deploy your smart contract. And that's why you don't need to provide it here. Is it clear, Rafa?
Yeah, thank you, Percival. Just to let know our viewers that you should not share your private keys because it's your key, which you can use to withdraw or to do whatever you want to with your wallet. So just keep it secret and just try to do not upload to GitHub or share to any people. So yeah, thank you, Percival.
Yeah.
That's right.
So thank you for showing them on the stream, but I'm assuming you're going to toss them out after.
Yes, just
exactly.
a test account. There is no nothing valuable there, and we really need those test accounts. And if you don't know how to create your own COTI test network account, I advise you to see our last live stream last week. There are some examples that Davi, Rafa, and I provide you on how to create your COTI test network. But in case you don't have this COTI test account, the first time you run the hard hat script, it automatically creates that for you. So that's not an issue either. You just need to fund that using a COTI faucet. Okay. Fingers crossed, I'm gonna run now the command to deploy our smart contract to COTI test network.
It's actually interesting in case it wouldn't work to see if it can detect why in case there's an error somewhere. But
let me see.
It looks like it's not causing any troubles.
Yeah, the weird thing is not outputting the address of the script, right? So you needed to. It's like it wasn't. It looks like it wasn't saved. I forgot to save it. Okay, now it's gonna run. Okay. Well, that's an interesting thing. It says that the Capibara was not compiled correctly. So let's see if the Capibara was correctly compiled. I'm gonna run again the command to compile to make sure that. It's taking a while to run. It seems it created the contract correctly. All right. Now you see the compiled version, right? The first time I run, I didn't see the JSON version created here. So now I see I have the compiled version, right? So now it seems it's compiled correctly. Let me try to run the deploy script again. Now it's taking a while. Okay, so the first time it didn't work because I forgot to save the Capibara the smart contract. It was here on the editor, but it wasn't saved. So when I compiled, it didn't compile anything. So I came here, I saved the smart contract, compiled it again, and now it has been deployed successfully. So let's go to the Blockchain Explorer, and let me just search for the address of the smart contract. All right, so it says that smart contract was created 55 seconds ago, and it's here. It's available on the blockchain. So when we compiled this smart contract, we expected it to have created some Capibara tokens for us, right? So let's go to MetaMask and add this new token here. So I'm gonna select the COTI test network. and I'm gonna add the address of the smart contract we already deployed. You see it already found the symbol, it's copy. And here it is. But as you see, it's encrypted, right? I don't know how many tokens I have. And I don't know how to interact with that token.
So this is a random number.
Yes, it's a
amount.
random encrypted number. So now I need to create another script to interact with my token and get the balance, right? So I know how many capybaras I have. Because if I see here, I know I have some capybaras, but I don't know much about it because everything is encrypted. So I'm gonna create a second script to decrypt that information so I can make sure that I really have 100,000 capybaras. So that's our next goal, to create a script to be able to interact with our private token. And of course, I have also created a prompt for that. So let me switch back here. I have created here a second prompt and some more complex prompt to create another script to decode the capybara balance I have. It's also gonna be a hard hat script for that. Write a hard hat script similar to getBalance.ts. That's a simple script that I have for getBalance that gonna invoke the balance-off function. Balance-off function is a function that's provided here on the COTI smart contract documentation that offers you the balance of your token address, right? So I'm gonna create a script that's gonna call this function on the capybara.sol, and you're gonna display the balance of the contract deployed, and this is the address of the token. I need to replace it with the address I have just deployed the token here. I'm also, I think I just copied the prompt twice here. So one time should be enough. And this is really the most delicate part because it's gonna use CodeEthers.js to do that. So I'm gonna also add CodeEthers as one of the dependencies here. CodeEthers is the library that we use to we interact with private information. So this is a hard hat script that's gonna use that library to invoke the getBalance function of the smart contract and return how many capybaras I have here in my address. So fingers crossed. Let's see how it works.
And is it taking longer because it has to deal with all
Yes,
this encryption methods?
yes, it has to deal with lots of information. But what it really needs to do in the end is to call that function from the wallet, see here, that decrypts my balance. So it has lots of dependencies, but what it really does, it is that it calls this kind of line from the COTI's library that decrypts my balance and shows my balance decrypted. So in order to decrypt my balance, it needs some information like the contact address, the account I'm gonna check, my private key. It already found it using the env file that I stored, and the AS key, which is the key I use to encrypt my private key to decrypt and encrypt information from this contract, right? So it has to figure out all those details, right? It needs to figure out which private key to use, which AS key to use, what's the contract address it's gonna need to check, what's my account, and information about the contract itself. That's what we call ABI. It automatically finds which function of the contract calls. And then it also uses the MPC library to decrypt my balance here. It's not something that complex to do, but the AI really makes this process really easier than writing all this script yourself. So let's see if that script works. So get Capibara. Okay. And also the same way there is a command to run the deploy, you use hard hat to deploy the script. We also gonna use hard hat to run this balance script. Now instead of capibara.ts, I'm gonna run a new script that's called get Capibara balance.
So you have multiple versions of this balance?
There is a
script?
standard balance script, and this one is empty, and this one it just created. So we are running the code that Gemini has just created, and we are hoping for the best.
Okay.
So let me just stop here. Oh no, I had deployed. I had run the deploy script again. I don't want to run the deploy script. I want to run the get Capibara balance. Oh, the beans. There is a. It's get Capibara, not get. There was a typo here. I need to have Capibara balance.
Capibara balance. It's a B. Yeah.
Yeah. Let me just.
Instead of a P.
One more time.
Reducing the tab.
I'm sorry, Rafa.
Nothing. Let's go. Okay, cool.
Okay, as expected. So it went to the smart contract address we just deployed. It's using my COTI wallet here. It's getting the balance of this COTI wallet from this contract here. If we can see that's the address of the contract we have just deployed. It ends with 6807F, so that's the contract we have just deployed. Here we can see the encrypted balance. That's the same thing that we probably see here on the MetaMask, right? This is the encrypted balance. And here is our decrypted balance. Our decrypted balance is 100,000 capybaras, and that's what we expected. That's what we asked our smart contract to do. When we deployed our capybara smart contract, we asked it to create 100,000 tokens and transfer that tokens to our account. And now we can see that the contract worked as expected. It created 100,000 capybaras, and it deployed here to our address. So the contract is working as expected. One last thing we can do is to create another function so we can mint some more capybaras to our account. What do you think? I also have prepared this prompt for that.
There's never too many capybaras.
So let's now mint more capybaras using the same contract and see if we have those capybaras added to our wallet. Okay, so let's go back to our cursor, and I'm gonna ask it to create a new. Now I'm gonna change the address of the contract, right? The contract address that we deployed was this one. Okay, so I'm gonna now create our third and last script, hopefully, to mint more capybaras. Oh, it says I'm running out of tokens credit.
Tokens?
Yeah.
Of requests?
Okay.
Yeah.
As you see, I'm using the free version of Cursor here. So, since I'm using the free version, sometimes I run out of credits and I need to switch the. Okay. Now it should work.
So what did you just do? That's it. You have different...
Yes, I've switched from Gemini
What
25 Pro to Gemini 2.5 Beta.
Which is a different set
Yes,
of credits to use
yes.
every day.
In case I run out of Gemini credits, I can run some cloud credits. Okay, so it's creating here a hard hat script to mint capybaras, right? And the amount of capybaras it's gonna mint me is like
10,000.
10,000. We need to make sure, yeah, 10,000. I already have 100,000, so ask him to create 10,000 more. I can adapt that to something else if needed. Okay, so I'm gonna here on the scripts library, I'm gonna go create a new script called Might Capibara. I'm gonna hit the apply button here. Need to make sure that the address are correctly. The contract address, not sure if that's the right contract address. Let me see here. No, the contract address is that one. Okay. Here's how many capybaras we want. We want 10,000, right? Not 5,000. So I'm gonna see here it uses the COTI ethers to invoke our contract and call the might function that's gonna add that new capybaras to our address. Here it's gonna show us the address that it's gonna add everything. Maybe it's gonna ask us. Let's see. Let's gonna run that script. And that script is called Mind Capybaras. So as I
Did you have to give that one also verification that you were the owner? Like, did you have to give a key for that one as well?
Yes, everything really runs on using the ones that we store on our environment file. So we keep an environment file with our credentials here, and hard hat is able to read that script.
Yep. Okay.
Okay, so it says here that there was a transaction that was executed, so we can look on the Blockchain Explorer for this transaction. Here is the transaction confirmed, so we can look for this transaction, and it says that it might successfully 10,000 capybaras. Let's look for this transaction here. Okay, so the transaction really executed correctly. It interacted with the smart contract address using my personal address. Okay, so let's go to MetaMask. You can see here that the number of capybaras I have, I think it has changed, right? It was a different number before. But how do I know how many capybaras I have? I need to run the capybara get balance script. So I'm gonna run the capybara. We already have a script for that, right? So let's run it again. Okay. Now it says I have 100,010 capybaras as expected, right? I used to have 100,000 capybaras. Now I have 100,010 capybaras because I just minted 10,000 capybaras to my address. And I can just run over and over again until I have enough capybaras. So if I run the script again, the mind script again, it's gonna run more capybaras for me. 10,000 more capybaras for me. Let me just refresh my screen. Yeah, you see here that my capybara encrypted number just changed, right? And when I see that information decrypted,
Yeah.
oh, I just run the mind script again, and I gave myself 10 more capybaras. So now I should have 130 capybaras. Let me make sure.
I do not see a problem here. So.
Well, after this call, you just send me your private address, and I'm gonna give you everyone who wants some private capybaras to play with. So here it is. I have 130. I'm sorry, 130,000 capybaras. Okay, I think I have enough capybaras for now. And that's the end of our tutorial. Any comments?
Yeah, so the amount is it's not visible, because it gives you random numbers in the wallet if you look at it. But you see the transactions on chain, as in it is visible that something was sent.
The transaction here, it only says that this smart contract was invoked. Everything else is private. So if I go here on my address, I don't see any capybaras here. So everything
Nice.
is kept private. You only see the Percival, which is not a private token, it's a public token. So that's one of the cool things of the COTI network. It allows us to have the standard ERC-20 tokens and private 20 tokens. So we can decide what kind of information we want to make public and what kind of information we want to make private. We have full control of that.
And you don't need any additional plugin from MetaMask for this. Just add the network and you can view them there.
Using MetaMask, you can see the information encrypted. There is a project that's working on creating a new plugin to MetaMask where you can decrypt that information without having to create your own scripts, right? So in order to interact with tokens, we have created those scripts that we can see the balance of the token and such, right? We can't see that directly on MetaMask. So the COTI team is working on some extension to MetaMask, so you can use MetaMask to see the encrypted. You can store your private keys on MetaMask, right? The ES key on MetaMask, and you can interact with the private tokens and the private smart contracts using MetaMask. So far, the current tools that are available, in order for us to do that, we need to write our own script, and we can of course integrate those scripts we are creating on our own dApps and use them, right? You don't need to run everything command line. You can integrate those scripts to a UI so the user can interact those scripts. But I think that would be the subject for a next live stream.
Great. Well, what happens if we want to make a withdrawal or a transaction to another account? It will be also a private operation?
Yes, it's also a private operation. We needed to create another script to do the transfer. So you see here that I have created on the capibara.so, I have created a transfer implementation on the smart contract. Is a private transfer, right? So it also runs an encrypted function to do that transfer. If I try to transfer those tokens using MetaMask, it won't work. It's gonna provide you an error. So
Okay.
in order for me to transfer those tokens, I needed to create a script that invokes this transfer. So it will use my AS key to do that kind of transfer.
Okay, got it.
Well, and that's all the fun I have for today, folks. Thanks a lot for sharing that with us and our community today. I think it was very cool, and in future live streams, I'm gonna do more things with COTI private tokens. It was really fun working with Capibaras today.
Thank you
Thanks
so
a
much,
lot
Percival,
for watching.
today.
Stay COTI.
Bye bye.
Stay COTI.